Or if I just called your name, you need to stay inside for recess. It's not even a nice day. Or you need to be in working for recess until those are done. Tomorrow they will start new, so try to get them done and out of the way right away. Exit ticket, if that's not turned in, or if you didn't turn in your weather activity yesterday, those are things that you don't go outside for. Now, I'm reminding you guys and all my other classes that don't wait to be put on ICU. If you know you didn't turn something in class on time, don't wait for me to put you on the ICU. Okay? Just come in at recess, finish it up, and get it turned in before it gets put on ICU. Does that make sense? Okay? Now today, well, let's review before we move on to what we're doing today. When I say mean, you think average, right? When I say median, you think middle. And what do you have to do before you find the middle or the median? Least to greatest. It's so important. It's not the middle of your data. If your data is not least to greatest, off the calculators. That's my second warning. Thank you. Okay. When I say mode, you say most often. The number or numbers that you see the most often. When I say range, you say subtract your difference, right? Difference means you subtract the highest and the lowest. You're finding the distance from the values. Good. So you might wonder what MAD is, but if you looked at the top of your notes, this is the notes I was referring to. Make sure that you had by the door, the MAD notes. Make sure you don't lose mean, median, mode, range notes. We're going to be coming back to that next week to finish the back of those notes. Okay? So look at your MAD, and that's an acronym for mean, absolute, deviation. So if we break this apart, if we break those words apart, mean is the average, okay, one number that best represents all of our data. Absolute, do you remember absolute value? Okay, absolute is the distance from zero. What do we remember about distance? Yeah, never negative or positive, or excuse me, never negative. We should stop there. Distance is never negative. It's just how many steps from zero. And then the word deviation means how far from. Okay, so what mean absolute deviation is? It's the average distance of each of these data points from the average. So we have 3 steps here that I've broken down for you. Essentially, you're going to find the mean of your data values. We're going to find the distance of each value from the mean, so distance, and then we're going to find the mean, the average of those distances, and then we're done. So I think you'll kind of find that you like it because it's kind of steps. You do this, 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 but we're working with a lot of numbers again today, so you'll find that it's important to have strategies so that we don't make mistakes. So let's go ahead and find the mean. Can you guys add these together and tell me what you get? Let's find the mean of that data. Oh. Go grab one from the, well, add? We all agree on that? Multiple? Okay, so everyone write this with me. 57 is your total. And remember, mean, we have to divide by the number of values, which is 6. 57 divided by 6 is 9.5. Okay, let's circle our average. That's our average. That's our mean. That's one number that best represents the center of all of the numbers listed above. Okay? Step 2, find the distance or the absolute value between each data point and the average. So take a look here. As we're going through today, I'm going to try to show you very neat ways to show your work. So now we have to list all of these data values. So I like to kind of split them in half. What do we have? So we have 10, 7, 11, and then leave some space. We have 20, 3, and 6. You need to be writing this on your notes. Flip it around so you can figure out where we're at. That's not where we're at. Flip it around. Follow along, please. The first thing I said is on your notes. Does everyone have that down? So how am I gonna, I need to find the distance. You don't need to draw these arrows, but I want to connect. I want to figure out how far away is 10 from 9.5? How far away is 7 from 9.5? What am I going to do with all these? subtract. Now, so I'm going to show you a quick way. You could write minus 9.5. Okay, and we can put this little subtraction sign by them. Instead of writing minus 9.5 6 times, just draw an arrow. I don't mind that. But look, be careful. Make sure you have like an equal sign coming from each of them still. And we'll write minus 9.5 over here one more time. Draw an arrow. And make sure we have the equal sign so we can tell what our answer is at the end. Now remember, it's absolute value, the distance. So 10 minus 9.5 is 0.5. Now, if you type into your calculator, can you type in 7 minus 9.5? Let me know what you get. Negative 2.5, but is distance ever negative? No, so get rid of the negative and just write 2.5. Then 11 minus 9.5, what do you get? 1.5. Now listen, these numbers, they seem close, but you have to be really, well, they are close, but you have to be really careful when subtracting, because you could get mixed up with the halves. So I would encourage you to double check with your calculator. What's 20 minus 9.5? 10.5. 3 minus 9.5. 6.5. And then 6 minus 9.5 is 3.5. So all of those, that's how far away they are from the average. Okay, so now what we need to do, I should have left myself a little space, and hopefully you can squeeze it in too, is we need to have a strategy. We're working with a lot of numbers. Okay, so if we look at step 3, it says find the mean or the average of the distances. Now, I would encourage you to draw a line and add each row and then add them together. So in case you mess up, okay? Remember, that's where we're doing a couple at a time. So what is this first left side? What's that equal? 4.5? Yes. Okay, 4.5 for this one. And the right side is what? 20.5. And then don't forget to add those together, and we get 25. So down on step 3, does everyone understand what I just did there? We just added all the distances together, but we just did it in a strategy where we don't make a mistake. So now we're just finding the average of those distances. So we have 25 as our total distance from the average, but that's not a best representation of those numbers up there. Don't forget to divide by the number of values again. Divide by 6 and you get 4.16 repeating 6, correct? So what do we use? If it doesn't tell us to round, what do we use to show a repeating number? Yeah. Bar notation over the 1 and the 6, or just the 6? Just the 6, because only the 6 is repeating. So take a look up here, guys. Make sure you have this written in step 3. Do you have this equation? So now let's box. We're going to box our answers. That is our MAD. And sometimes it's nice to write, maybe underneath it, write MAD, and in your head, okay, say what that means. Mean absolute deviation. So that the more you say it, the more you think it, the more you'll remember what this process helps you find. So number 4, I'm not going to make you write down what it means, but I want you to listen and try to understand what it means, okay? What this 4, I'm just going to say about 4 means is that each of our data values are about 4 away from the average. So visualize our center number, right, our average. All of these data values are within 4 of the average. Does that make sense? Okay, so that's what MAD means. That's what mean absolute deviation means. Okay, so let's go to the bottom. So a data set with a smaller mean absolute deviation, that means the data values are closer to the mean or the average. A data values with a larger or big mean absolute deviation, that means our values are further from the mean. They're more spread out. Does that make sense? So like if my mean absolute deviation was 25, that would mean that my numbers are not very close to that average. You can go ahead, thank you. Okay. Now, I hope that you can start to understand what mean absolute deviation is. If you're not following along, though, you're not going to understand. I hope that you can start to understand. I think that you'll have the process down by the end of the day, just because it's kind of like you do this, you do this, you do this, right? But we'll continue to try to learn about what it means, what actually understanding. Okay? So if you would flip to the back, we're going to do one more together. One more together. So a 6th grade class, or a 6th grade homeroom class was asked about how many movies they see in a year. Find the MAD, or mean absolute deviation, of these. So the first thing we need to do is what? Just leave it. There's going to be more people coming. Just leave it. Well, the first thing we need to do is what? Go ahead. Yeah, we need to find the average. So let's go over here. Can you guys add these together and tell me what you get? Let me know when you're done with that. We need to write our equation. Consistent. It's okay if you're not done. We'll go with what if I hear multiple. Good. So 97, let's write our equation. 97, and is that our average of those numbers? No way. Okay, we don't have anything close to 97, so we have to divide by 10, which equals 9.7. Now, I would maybe right here write mean, so that you have that note. 9.7 is your mean, the average of the totals. Whoa, the average of your data, not the totals, sorry. Okay, and now listen, never round unless it specifically tells you to round to a certain place value. Does that make sense? Okay, so we're not going to round, we're going to leave it as 9.7. What do we do next? What do we do next? After we find our average of the data values, I'm looking for some new helpful hands as well. What do we do next? Yeah, we have to find the distance from all the values. So let's write down the values in a neat, organized way. So we have 10, 7, 7, 8, 9. I'm going to go 5 and 5 since I know there's 10 of them. 10, 6, 12, 14, 14. Yes. Well, the question was about how many movies they see in a year. That's a great question. That has nothing to do with our math work. It just said, like, if I said, about how many movies have you watched? And you'd be like, oh, maybe 7. You know what I mean? It's not exact. Hey, that's a great question. Okay, so does everyone have this listed? All right, so now, remember, we need to subtract the mean. So write minus 9.7 once. You can draw your arrow down, but make sure you have 5 sets of equal signs on each so that you know you're going straight across. I saw some nice and neat work from some people earlier. They just kind of underlined each of them to go straight across. That's up to you if that works better for you too. So same thing over here, minus 9.7. Can you guys go ahead and complete all of those, and then I'm going to have you fill me in on what you get. Okay? But so can we just go in order? What's the distance? Here, the first one. What about the next one? Next one. Next one. Next one. 0.7. Next one. Next one. Next one. Next one. And 4.3. Awesome. So check yours. Make sure you have all those the same. It sounded pretty consistent when everyone was telling me. And then what next? Raise your hand. I'd like to hear from somebody I haven't yet. What do we do next? Go ahead. Yeah, we need to add those all together. Now remember, chunk it off. So like do these 5, add them. Do these 5, add them. And then add those together to get your total. Let me know what you get. If someone could let me know the left side what you get, I'll write it up here. Just say it when you have it. $8.9 on the left. 8.1. Do we agree with that? Thank you. Let me know what you get on the right side whenever you have it. $14.9. Do we agree? Thank you. And then add those together, and we get, go ahead, 23. So now that we have the total of all those distances, remember we're finding the mean, the average again. So what do we have to do with 23? What? Divide it by the number of distances, which is also 10, and you get 2.3. And remember, it's kind of helpful to say, yep, this is my MAD, my mean absolute deviation. Let's refresh one more time on the process. Excuse me. We find the average of the data. We find the distance from each value, the distance from the average to each value, and then we find the average of the distances. Okay? Now let me tell you one thing. This thing in red here, the mean, I would double check that before you move on. Because if you have the wrong mean, what does that mean for everything else? Everything else will be wrong. So I would double check your average. Say, does that make sense? Did I remember to divide? Did I act correctly? And then move on. Does that make sense? Okay. So listen quick here. I can leave my work up here. You are going to finish number 1 and 2. And you're going to check with me. I'm going to mark them. When you are done, raise your hand and I'll check them. When you're done and you have 2 pink stars, you can come get a MAD maze or mean absolute deviation maze. Okay, you'll start right here. You cannot do all the work on the front of this. Please listen and don't start yet. You cannot do all the work on the front. Either get a notebook paper to put it side by side or show your work on the back. I don't care, whatever works for you. Does that make sense? All right, I'll get some music going. Now listen, working with a lot of numbers, so take your time, be careful. Go ahead and get started.